Now we're going to solve a few inequalities. Inequalities are solved just almost in exactly the same way you solve equations. You just have to be careful that if you multiply or divide by negative, you've got to switch the inequality. Okay, so 3x plus 7 is less than 5x minus 2. There's our inequality. We want to isolate x, same the left side, and we've got to get some number on the right side. So we subtract 7 from both sides. That's going to get us a little closer to where we want to be. Subtracting 7 from both sides, I don't have to read it all to you. You end up with a negative 9 over here, and now you have no unaccompanied numbers over here, no numbers that aren't coefficients of the variable, that are coefficients of the variable. Okay, so now we have 3x less than 5x minus 9. What are we going to do? Well, you don't want to add 9 to both sides. That's going to get you away from where you want to be, which is having all your x terms on the left-hand side. So we subtract 5x from both sides. So the 5x minus 5x goes away. We have negative 9. 3x minus 5x is negative 2x, so we have negative 2x less than negative 9. Now that you're on a roll, you're going to want to divide by negative 2, and that's going to give you x. Now the only thing you've got to be careful of is you reverse that inequality when you divide by the negative. And we end up with x greater than 9 halves. 9 halves is 4 1/2. Just to make sure we've got a decent solution, we could plug in, let's say, 5, which is just a little bigger than 9 halves, and we would get 15 plus 7, which is 22, and we would get 25 minus 2, which is 23, so 22 less than 23. So if x equals 5, this is satisfied. 5 is on this side of 9 halves, so we're pretty sure we're on the right side of 9 halves. Our graph for x greater than 9 halves, we write down, or we just draw an axis, a number line, okay, and on that number line we locate 0, and we've only got one number to worry about, which is 9 halves, so we can put it anywhere we want as long as it's to the right of 0, because it's positive. So 9 halves, put it here. Our graph then consists of all numbers that are greater than 9 halves. That would consist of all numbers on the ray described by this arrow, except for 9 halves, and we put an open dot here at 9 halves to indicate that the point where x equals 9 halves is not included in the solution. Okay? Now, let's take this inequality, which is really, in fact, two inequalities. 2/3 is less than x minus 4 over 5, and x minus 4 over 5 is less than 5 halves. We can deal with both of those inequalities at once by multiplying everything on both sides, everything in all three expressions by the same number, adding the same number, etc., etc., as long as we do the same thing to every expression. We start, as I continually remind people, we start by multiplying by common denominator. If we have denominators, our work is easier, less error prone if we clear our denominators, and we can do that by multiplying by any common denominator. 120 is a common denominator. We can multiply by 120 if we want to. As far as that goes, 2,400 is a common denominator. We can multiply by 2,400. In any case, all these denominators would go away, but it's more convenient to multiply by our least common denominator, which in this case is 30. 3, 5, and 2 are all relatively prime numbers. They have no common factors, so the common denominator is going to have to be the product of the 3, which is, again, 30, as you can verify. So we multiply everything by 30, every expression by 30. 30 times 2/3, 30 times x minus 4 over 5, and 30 times the 5 halves. Okay, 30 times 2/3, 3 goes into 30 10 times. 10 times 2 is 20. That's very straightforward. 5 goes into 36 times, so we end up with 6 times the quantity x minus 4. We could take a chance and simplify that at the same time, but better to do it in a separate step. We're less prone to error. And 30 over 2 is 15, and 15 times 5 is 75. So now we have this inequality. We then distribute, getting the 6x minus 24 here. Didn't change either of the numbers here or here. Now that we've distributed, we can add 24 to both sides, giving us 20 plus 24, 75 plus 24. It's going to give us 44 and 99. And that's 6x is going to be sandwiched in between those two. At this point, we're going to have to reintroduce denominators. So we have to divide by 6 in order to get to x, and that will reintroduce denominators. But we've got to do all this stuff here without any denominators. And all that's left is pretty simple. Okay, so we divide everything by 6. 44 divided by 6 gives us 22 over 3. 6x divided by 6 gives us x. And 99 over 6 gives us 33 over 2. Now that's if we want the mixed numbers to get an idea of where these go on the number line. That's going to be 7 1/3, and this is going to be 15 1/2. So we're going to put those numbers down here. Now I've written them as 22 thirds, 33 halves. Those will be the numbers here and here. Okay, x greater than or equal to 7 1/3. Okay, well, 7 1/3, that's our 22 thirds, and x is going to be greater than or equal to that. Well, that's going to correspond to this green ray. And that's an open ray. I'm sorry, that's a ray beginning at the open point here at 22 thirds. And actually that's not open, that's closed. So it looks open to me, but I did shade it in. And then x is less than 15 1/2, x is less than our 33 halves. That would be this. Now it says this is less than x is less than this, means this is less than or equal to x, and x is less than or equal to this. So in order for x to satisfy this inequality, it has to satisfy both this inequality corresponding to the green arrow, so it has to lie somewhere on the green arrow, and it has to correspond to this inequality, which corresponds to the blue arrow, meaning that x has to lie between here and here. Anything beyond this, and it's not on the blue arrow. Anything to the left of this is not on the green arrow. So the solution is here. I've indicated that in the orange line segment with, I'm not sure they're visible, the two closed points. So now I'm going to close them up real good just to make sure we see them. And there we have our solution and the graph of our solution.